Hello, in this video, we will be discussing the quotient rule. The quotient rule is a rule of differentiation that is applied when we have two differentiable functions dividing each other. Let's say we have a function which is u equals f of x, and it's equal to 3x squared plus 4. By differentiable function, what we mean is that 3x squared plus 4 in of itself, we can take the derivative of it, which means we can differentiate it with respect to x. However, we have another function, which is v, which is also a function of x, but to avoid confusion, let's call it g of x, and it's equal to 10x minus x cubed. We can see that these two separate functions, we can take their derivative respectively with respect to x on their own. However, when we have these two functions dividing each other, for example, let's say the first function u is dividing the second function v. So we have y equals u divided by v, or we have y equals f of x divided by g of x. Irrespective of the notation that you are using, it's still going to mean that y equals 3x squared plus 4 divided by 10x divided by x cubed. So in this kind of situation where we have a function that is composed of differentiable functions, we apply the quotient rule. So what is the quotient rule? First, we know that this numerator here is u, or f of x, and this denominator is v, or g of x. So the quotient rule states that dy dx equals, we take the derivative of u with respect to x, and we multiply it with v, minus, we take the derivative of v with respect to x, and we multiply it with u, everything divided by v squared. And this is the quotient rule. If you have seen the video on product rule, then you know that we have a way of memorizing the formula which will aid us to remember every time we want to apply the quotient rule. So we have dy dx, take the derivative of the first function, multiply it with the second function. Unlike the product rule, we will have minus now. Next, we will take the derivative of the second function, and we multiply it with the first function. And lastly, divide all by the square of the second function. Now let's solve two examples. Applying the quotient rule, dy dx equals, this is the first function, and this is the second function. The quotient rule states, take the derivative of the first function. The first function is 3x squared plus 4. So derivative of 3x squared plus 4 is 6x. Multiply it with the second function, which is 10x minus x cubed, minus, next we take the derivative of the second function, which is 10x minus x cubed. Derivative of 10x minus x cubed will give us 10 minus 3x squared, and then we multiply it with the first function. So we have times 3x squared plus 4. And lastly, all divided by the second function square, or the square of the second function. So we have 10x minus x cubed all square. And that's the way we apply the quotient rule. It's fine to leave your answer like this, except if otherwise stated, and you will have to simplify further. Another example. To take the derivative of this example, there are a few things we need to sort out first. So we need to start out this square root of x. We need to sort out this x squared at the denominator here. This x at the numerator here is not a problem, but we can simplify that. So simplifying, we have y equals square root of x means x raised to the power 1 over 2 minus 10x raised to the power minus 2 divided by x squared plus 5x open bracket 3 over 2x squared means 3 over 2 x to the power of minus 2 minus x over 4 means 1 over 4x. Now we can take the derivative using the quotient rule. So this is our first function and this is our second function. So dy dx equals, take the derivative of the first function. So we are taking the derivative of x to the power of 1 over 2 minus 10x to the power of minus 2. So taking this derivative means 1 over 2 comes down. We have 1 over 2 x raised to the power 1 over 2 minus 1 minus the minus 2 comes down, multiplied by the existing coefficient, which is minus 10 or 10, as we've put the minus at the front. Then we write the variable back, which is x, subtract 1 from the power. So to simplify, that's equal to 1 over 2 x, 1 over 2 minus 1, that will give us minus 1 over 2, minus times minus 2, that will give us plus 2, plus 2 times 10, that will give us 20. So we have 20x minus 2 minus 1, that's minus 3. And we're done with the derivative of the first part. So we have, next, we multiply it with the second. The second is this function here, the denominator. So multiply by x squared plus 5x 3 over 2 x minus 2 minus 1 over 4x. Next, the quotient rule says minus. Next, we take the derivative of the second part. So we take the derivative of the denominator now. The denominator is, as we can see, to take the derivative of this denominator, we need to apply the product rule. If you are wondering why we have to use the product rule, then please check the video up here or refer to the description below. We've explained when to use the product rule and how to apply the product rule. So using the product rule, the first thing we have to take note of is that this is the first function and this is the second function. So the product rule states the derivative is equal to, take the derivative of the first function. So we are taking the derivative of x squared plus 5x. So the derivative of x squared plus 5x is 2x plus 5. So take the derivative of the first function, multiply it with the second function. So 3 over 2x raised to the power minus 2 minus 1 over 4x plus take the derivative of the second function. So now we take the derivative of this. So the derivative is, derivative of 3 over 2x raised to the power minus 2 is minus 2 multiply 3 over 2x, then minus 2 minus 1 minus 1 over 4x, 1 minus 1. And lastly, we multiply it with the first function. So x squared plus 5x. So to simplify, that's equal to 2x plus 5 times 3 over 2x raised to power minus 2 minus 1 over 4x plus the second part minus 2 times 3 over 2 will give us minus 3x minus 2 minus 1, that will give us minus 3, then minus 1 over 4. X is raised to power 1 minus 1, that's 0, so x raised to power 0 is 1. Close the parentheses, then we have x squared plus 5x. So this is the answer. Let's bring it up here. So we just wrote what we have here, the derivative that we took, we just brought it here. So far, what have we done? We took the derivative of this first function and it gave us this. Then we multiply it with the second function, which is this, minus the minus here, the derivative of the second function. The derivative of second function gave us this. And then we multiply the derivative of the second function with the first function. So the first function is this. So we just rewrite that. So we have all of this, which is the derivative of the second function. It is multiplied by x raised to power 1 over 2 minus 10 x raised to power minus 2. And lastly, all divided by the second function square. The second function, which is x squared plus 5x 3 over 2 x raised to power minus 2 minus 1 over 4x the square. Quick summary again, what did we do? We took the derivative of the first function, it gave us this, multiply it with the second function, which is this, minus the derivative of the second function. We used product rule to calculate the derivative of the second function, and we got this, and then we multiplied it with the first function, which is this, and lastly, divided by the second function all square. As simple as that. One more important thing, you may be wondering, why did we put a big parenthesis here? And why didn't we put a big parenthesis here? So the reason why we put a big parenthesis here is because we have an addition sign at the middle here. So because there's an addition sign here, omitting this parenthesis will signify that only these two are multiplied. However, by including this parenthesis, it means all of this is multiplied by this. I hope that explains that. You may refer to the playlist in the description below for more examples on how to apply the quotient rule. Hope you found this video helpful. If you did, please leave it a like and subscribe to the channel. See you in another video. Thank you very much.